Hello, AP Calculus. So I'm here to give you an introduction to our next chapter on derivatives. So let's take a look at what we have here. So I wanted to start with something basic. This is the picture of just a random graph. I just graphed a random function. You can take a look. It's like 0.233x cubed minus 4x plus 3 minus 8 cosine x minus inverse tan. It doesn't matter. I just graphed a random function. What I want to show you is this. And you could try this on your own. You could do any other function. If you take a function and you zoom in on any point. So let's just pick a random point over here, and let's just try zooming in and zooming in. No matter how crazy your function is, as you zoom in further and further and further, it always turns out to be a line. And this is true on any continuous function. No matter what you do, no matter what function it is, no matter what point you pick, you can pick any point and just zoom in further and further, and as you keep zooming in, eventually your function will just exactly resemble a line. So the next question that all you guys have is, well, fun. So if my function at any point looks like a line, if I zoom in far enough, what is the slope of that line? Okay, and that's what we're going to be talking about now. So let's go back to what we were talking about with tangent lines and secant lines. I have another diagram here. So what we have, here we have just some random function f of x. This is just a quartic equation. So what we're trying to do, we have some point P, and we're trying to estimate the slope of the line, which is the slope of the curve, is just the slope of the tangent line at that point. So if we're trying to estimate the slope of P at this value x, we just draw the line right there, and that's the slope we're trying to find. So the way we're going to do this is we're going to take another point here, h units over. So at x, so here we start at x, now we're going to add up a couple points, now we're at x plus h. Okay, and then now we're going to take a line, we're going to take the point at there, and then we're going to take the line that goes between points P and Q, our secant line. Okay, so we're going to take that secant line. Now, let's go back and actually do some math here. Wrong one. Okay. What is the slope of that line? And that's something I wanted to talk about briefly here. Okay, so to find that, let's go back here and make a document. So we want to find the slope of this line, right? So point P, oopsie. All right. So point P is the point x, comma, f of x. And point H, or sorry, not point H, point Q, is if we've moved over h units, that's x plus h, and then the height of that is f of x plus h. Okay, so if you wanted to find the slope between P and Q, the slope between P and Q is, thinking back to just y minus y over x minus x, that's how we find slopes. So that slope would be f of x plus h minus f of x divided by x plus h minus x. Now, a lot of the cool kids recognize, of course, that the x's cancel in the denominator. So you could write this as f of x plus h minus f of x divided by h. Again, this is the slope of the secant line between P and Q. Now, what we're going to do now is just drag those points closer and closer together. So what happens if I make that h smaller? So if I bring those 2 points of the secant line closer and closer together, and in fact, what you'll see is I bring them infinitely close, doesn't that slope just turn into the slope of the tangent line? And that's the key part of this lesson, is that as we take those 2 points of the secant line, and we take that limit as they go closer and closer together, it gives us the slope of the tangent line at P. Okay, that's crucial, and that's the main reason I made this video with the visuals. As we bring these 2 points closer and closer together, we get the slope of the tangent line. Okay, so let's write this down and think about this as a limit. So then if we want the slope of the tangent line, all we're going to do is bring those 2 points infinitely close together. And how do we do that? By taking a limit as h goes to 0 of this slope between 2 points. So that's all this equation is. It's just the slope between those 2 points as we take a limit as those 2 points get closer and closer together. And this, my friends, this equation right here to find the slope of the tangent line, this is the definition of a derivative. It is defined as a limit. What happens when you bring those 2 points infinitely close together? That's how you find the slope at any one point. Okay, so the next video we'll do some computation. This video is all about theory. Hope you enjoyed. Hope this is useful, and thanks for watching.